Hey there, Year 11s. We're going to look at Level 1, 2011, Chance and Data. And we're just going to dive straight in. Apart from, I'll do a special shout out to Georgie from St Andrews. So there you go, Georgie, there's your special shout out. Okay, let's get underway. Now, it's probably best if you're wanting to follow this, if you pause here and read through. Otherwise, I'm just going to keep on going through. And we're looking at this data here, or we're given a situation where a student's looking at this data and they have to interpret it. And so we've got all of the statistics here, and then we've got some questions here. So the first question is asking us, what is the height of the tallest person? So we want to go to our graph and have a look here at what our two variables are. So we've got arm span on this axis, height on this axis, and so we're really looking for the highest along here. So that's that point there, and it looks like it's a little bit over 200 centimeters if we track down. Well, we can look at our statistics as well, because we've got height and arm span here, and under height, if we come down to here, we've got our maximum of 201. So that's our first question there. We've got 201 centimeters. What is the height of the person with the smallest arm span? So if we find that person on the graph, the smallest arm span is here, and they have a height of 160. And so we'll write that down, 160 centimeters. Okay, how many people have an arm span between 120 and 135? So we'll just scroll up to the graph again. So 120 is coming along here, and 135 is along here. Just check up, make sure we're not missing any. And so it would appear, I'm supposed to be looking at arm span, and that's height. So we'll track across from arm span. So there we go, 120 and 135. There we go, I've got two people with an arm span between that length, and so we can just write 2 for that there. Okay, so we can rip through that pretty quickly, and these questions here are really just achieve level questions, and not a lot more that we can do to them other than that. Okay, the next question is asking, why is a scatter graph appropriate to show the data that Tuahu had collected? Well, if we look at the graph, we've got two variables here. We've got arm span and we've got height, and so when you're comparing two variables, a bivariate graph is a good graph to use. Also, it's a great way to sort of spread out the points to see if there's any sort of relationship between arm span and heights, and so that's where we get this cluster of arm span and heights here that show us a bit of a relationship. So it's just a matter of writing those things down, really. So we can say this data is bivariate, and so can be shown in a scatter graph. And this allows data to be presented in a way that can show if there is a relationship between arm span and height. Okay, so I mean, everyone's going to write something different here, but I guess the key points here is that a scatter graph is good for showing bivariate data, so that's where you've got two variables that you're comparing, and this is a good way to see if there's a relationship between arm span and height. So if you've got those key points in there, similar words, that's great. Okay, and the next question is saying there are some points in the graph that seem unlikely measurements for a Year 10 student. Give the height and arm span for 3 points that seem unlikely. Well, look, if we go to our graph, we've got a few points that could be seen as unlikely. We've got these ones here. We've got a few here. I mean, these two are unlikely because they're so short. I mean, 105 centimeters, you're talking about possibly the shortest person on the planet. And then these people here, their arm spans are so small. We're kind of either looking at people who have had an arm chopped off or T-Rex style sort of hands, but they really don't fit in with the rest of the data. Even this one here, an arm span of 100 compared with a height of 160 does seem out of place. Some of these ones here seem quite far out of place. These ones up here, not so much. They seem at least close-ish to the line. So really, you've got a few points to choose from there. So I'm going to choose these two because they seem so out of proportion between the height and the arm span. And this one here, simply because it's quite unlikely in a set of data this small that you'd have someone that short. So it's asking us to give the height and arm span for 3 points that seem unlikely. So what we'll do is make a little table here to keep it nice and tidy. So we'll go height, arm span, and we'll come down 3 lines here, and 1, 2, 3, so for our 3 ones. So our first one here, our height appears to be about 105, while our arm span is 160. So I'll put that one in. So 105 centimeters and 160 centimeters arm span. Okay, our next one, our height is 160 and our arm span is 60. So 160 centimeters and and arm span was 60 centimeters. 60 centimeters, and our last one here, we have a height of about 174, 173 perhaps, and a arm span of 80. So 173 and 80 centimeters. Now I've just chosen 3 there. You could probably choose some other ones there as well, but we'll talk about those ones. Now in terms of achieved and merit, identifying points is basically achieved. If we're going to give an explanation about this, that can lead us on to merit. So I'll just box that off so I've got plenty of room here, and we'll start with our point number 1, which is 105 and 160. So point 1, so say something here, this seems unlikely. Firstly, because 105 cm is so short, probably not impossibly short, but certainly a very, very rare to have that kind of height. So because 105 is so short, and arm length of, what have we got, 160 cm seems so disproportionate. Okay, alright, so that's one explanation there. The other two have similar explanations because the heights are tall and the arm spans are short, so I'll wrap them up in one sentence. So I'll say 2 and 3. Since the arm spans seem so small in proportion to their height. So small in proportion to their height, more so than would normally be expected. Okay, so that's just an example of what you could write, and certainly you could identify different points and come up with different reasons, but that's just an idea, and that's really a merit question. Okay, so looking at question D here, Tuahu concludes from his graph that the statement made by his grandfather is correct, that on average a person's arm span is the same as their height. Is Tuahu's conclusion valid? You should give at least 2 reasons for your answer. Well, look, here once again this question is just so open. You could say yes, it's correct. You could say no, it's correct. You could say no, it's incorrect. But you've really got to decide, what you're going to do, and just back it up with some statistics. So you could even say in some ways yes and in some ways no. But whatever you do, you need to back it up. So I'm going to choose yes here. So I'll just state that so that I know where I'm going, and then I'm going to think about why I think it's yes. So I'm just going to go back to the graph for a bit, and we can see we've got this line of best fit that's been drawn in here, and it does seem like a lot of data kind of collects around there, and we can see it's going through the corner of each square, and if we carried that on, it would actually eventually go through 0, 0, which basically means that the rule or the line of best fit really follows that. So that's sort of one reason we could say that. So write that down. Yes, since the line of best fit, the line of best fit is y equals x, meaning in general height equals arm span. Okay, so that's one reason there. Another reason that we could have that supports that is just the size of the sample here. Now we've been told that it's 100 randomly selected Year 10 boys and girls, and so that's a good size sample. It's more than 30, so we'll say also since the sample size is sufficiently large, this helps us make this inference, I guess. Okay, now there's nothing to stop you from doing a few more reasons, so perhaps we could just look at the statistics in the table, and just looking at here, we appear to have similar mean. Our minimums are a bit different, but our lower quartiles are similar, medians are the same, upper quartiles are very similar, even our maximums are very similar. So we'll just say also many of the sample statistics for height and arm span are nearly the same. And it's just worth backing up that with an example. So, for example, height median equals, and we'll quote that. So the height median was 165. Height median is 165 centimeters, while arm span median is also 165 centimeters. So having an example in there just sort of shows that you know what you're talking about. You're not actually just making things up. Okay, so just a recap of that question. So that those first three questions there, those are all achieved questions. So you might expect to see those marked with R's, meaning with U's, meaning achieved level, or if you're thinking solo taxonomy, those are multi-structural questions. Question B, depending on how you answer it, you can get anything between U to T for that one, so anything from achieved to excellence. Question C, if you've made two really valid points there, that one would be R, so you could get anything from U to R for that one, R being merit level. And for D, if you've answered D fully, then you'll get a T for that. So, depending on your answer again, could be U, could be R, could be T. Yeah, just depending on how much detail you get into there. Okay, so that's question 1, and now we'll stop there and then we'll go